So I was asked to do a recording of exam 1, and I decided, well, what the heck, I'll give it a shot and see how it goes. So this is asking us to do the difference quotient. So f of x plus h minus f of x divided by h. I like to do my functions, I like to think of them as blanks that I'm filling in the blank. And so what am I putting into this blank right here? I'm putting in x plus h. So that's what I should have here first. So 3 times x plus h. So imagine right here is going boom right here, right? Over, and then x plus h plus 2. And then minus, boom, x is going in there. So right in here. And of course, don't need the parentheses here. All over h. And actually here in the denominator, I don't need the parentheses, but here in the numerator I did because there's no coefficient right there. And so I noticed, well, I'm supposed to simplify this, got a complex fraction, you multiply by the denominator. So I'm going to multiply this numerator right here by x plus h plus 2 times x plus 2, this denominator and that denominator. And what you do to the numerator, you got to do to the denominator, x plus h plus 2 times x plus 2. And this is a binomial, I'm going to distribute it. So when I distribute it, this cancels here and gives me 3 times x plus h times x plus 2. And in fact, if I liked, I could do a little more on this, but I think I'm going to take the extra step. Minus, and then when this, right, this monomial is multiplying to both of those pieces, the x plus 2's, and I get 3 times, I lost the x plus h plus 2. And in the denominator, I don't want to multiply that business together. If I do, then I'm wasting my effort. Because what I'm hoping will cancel was h, so there's no reason to multiply the denominator together. In the numerator here, when I multiply that together, I'm gonna say this is 3 times, and then when I multiply x times x is x squared, and 2x, and xh, and plus 2h, right? And then I'll distribute the 3. So this is 3x squared plus 2 times 3 is 6, 6x, plus 3xh plus 6h, all minusing, right? 3x squared minus 3xh minus 6x, all divided by what I had in the denominator without changing it because I was hoping to cancel h and it's already factored. And so the numerator, I'm hoping to multiply all that business together and cancel h. So 3x squared minus 3x squared, and this and this and this and this leaves 6h. So the h, no other pieces, the h's cancel out, so it leaves 6 in the top, and x plus h plus 2 times x plus 2. No need to multiply that together. That's perfect. That's wonderful. Go on to the next one. So odd, even, or neither. The test is to look at what f at negative x is equal to. Put in your blanks again and fill in your blanks. So with negative x here, with negative x here, and negative x here. If you get what you started with, it's even, and if you get the opposite of what you started with, that's what I started with, it's odd, right? And so in the numerator, I get negative x to the third. Here, I get x to the second. Here, I get plus 2x. And here's where it just cannot be what I started with, and it can't be opposite of what I started with, because if I pull this negative that I can write, beginning algebra students are always plagued by what happens with that negative, but that negative can go, this is the rule that they give in beginning algebra, that you can put that negative in the front. And so when I do that, you can see that I just don't have what I started with because this is a plus and it's a minus there. So it's not opposite of what I started with, so this is neither. And you do have to show your reasoning. It's not good enough just to say that it's neither, right? You have to show why you think it's neither. And then here it's asking us for the average velocity, which is the slope. And this is a time interval. So I can write this as an ordered pair. 2 and 2 goes with an output or a y value of 20.6. And 4 is my input and it goes with a output of 79.2. And so the slope is the subtraction of the y's, 79.2 minus 20.6, over 4 take away 2, the subtraction of the x's. And when the dust clears there, I'm going to get, let me see here in my calculator, 79.2 minus 20.6, and in the denominator I have 2, and so this thing here is 29.3, and you should always say units when you have something, when you have the units. And so the S was this is S, right, in feet, and this was in feet. So the numerator is in feet. So this is feet, and then per, and then what do we have here? Seconds, right? So feet per second, and that makes sense for velocity, right? The average velocity is the slope, and feet per second goes with velocity, so that's all well and good. Here it's saying f at g at 3. And so this says go to the function called g, plug in 3, and tell me what you get. So when I plug in 3 right into the blank, right? The blank is here, and I'm plugging in 3. And what I get when I do the arithmetic, I get 1. So this is f at 1. So that says come to the f function and put into the blank 1. Almost ran into my g function there. Put in 1, right? Put in 1 and tell me what you get. So when you do that arithmetic, you get 2 minus 6 plus 2. I think that's minus 2. And so that's what we get there. F minus g, this is saying in general, not at a particular point like that one is. So, and when you're subtracting, you got to make sure that you use parentheses. So this is this minus this. So we have this for our f, 2x squared minus 6x plus 2 minus x minus 2. So this is 2x squared minus 6x plus 2 minus x plus 2. So that's 2x squared minus 7x plus 4. And so we did a good job on that. So number 5 is asking us to find a limit. It reminds you that finding a limit is like doing a proof, so it's not just good enough to say the answer, even if the answer is correct. And it says don't use a table of values. They want you to reason it out using the limit laws. So when I go for the first limit law, which is can I use substitution, I get 1 minus 3 over 3 minus 3, and I get negative 2 over 0, which tells me it's an asymptote. So now I just have to, in fact, it's a one-sided, right? This is one-sided right there, right here, one-sided. So that tells me the answer is either positive infinity or negative infinity, and I only have to reason out which one it is. So in my little mind, I'm thinking, if I was slightly before 3, then the numerator, 1 take away 2.9, right, slightly before 3, would be negative. And the denominator, slightly before 3, 2.9-ish, you know what I mean, slightly before 3, would be negative as well, but nearly 0. That's what makes it infinity, is that it's getting to 0. But what makes this positive infinity is it's negative divided by a negative. So this is positive infinity. And this is my reasoning why. Here, when I substitute in, that's my first limit law. So I'm plugging in, and I notice that, oh, this is 0 over 0. This is indeterminate, and that means that I need to work harder, probably factor it, because it's a polynomial over a polynomial. So when I give this thing a factor, x plus 3 times x minus 3. The numerator is a difference of squares, and the denominator is x plus 3, x minus 1. And I don't care how you factor it. I use here a difference of squares formula. I guess it's a formula. And down here, I use unfoil. And so whatever method that you like to use, you notice the part that was making it 0 over 0 is just canceled out. I expected that that would happen, and now I can use substitution because that's the limit law, right? So this is negative 3 take away 3 over negative 3 take away 1. I don't write the limit anymore because I've taken the limit. And so I get negative 6 over negative 4, which I should always reduce. That's 3 over 2. And then I can go on and do the next one. Oh, I hope I pushed record. Might have nada. Oh, that'd be awful. I'm so tired. Would not be a good news. So my first thought is it okay to substitute? So I'm plugging in 2 there for all those spots, and it's 0 over 0. So it's again indeterminate. And so this time I notice that I have absolute value, which means I have to use the absolute value definition. And that is, it's either the same, the same, and I changed that to a minus. I changed it to a plus when it was a minus, and that's if x minus 2 is greater than 0. And you want to solve that. And so when I solve that, do you guys agree that's x is greater than 2? And so I'm going to just erase it and solve it because I can solve that in my head pretty easily. Greater than or equal to 2. And then, or it's the opposite of x minus 2. And that's all you have to do is change the symbol, and that's if x is less than 2. So I'm looking at, well, where am I at? Well, it says stay smaller than 2, so this is the one I should use. So I get the limit as x goes to 2 from a little bit smaller than, and I have to give that a little factor, right? So that's x plus 4, x minus 2. And I'm going to be using this, so that's minus x minus 2, right? Like that. And those cancel out with one another, hot diggity dog. And then I can do substitution to find the limit. So I plug in 2, and I get 2 plus 4 over a negative. Well, it's actually negative 1 is what it is because those both reduced out to be 1, right? So I get negative 6. And then I'm done. So here, when I plug in to do substitution, I get 4 minus the square root of 16, which is 0. And so let's see if we get 0 in the denominator. 16 squared, I'm not thinking about what it is, but this is 16 squared, right? So it is 0 over 0, indeterminate. I could have got out my calculator. It's 256, I think. Losing how to spell indeterminate. Sometimes I do that when I'm tired. I can't think of how to spell things or say words correctly. It's like a curse, I think, sometimes. So here I'm going to multiply because I got square root, and it's a binomial, by the conjugate. And I'm hoping to cancel the part that's making it 0 over 0. And so as x goes to 16, so that means I'm hoping to cancel x minus 16. So I already know what I'm hoping to cancel. And you can see that in the denominator, oh, I think I have x minus 16 down there, right? And so, or 16 minus x, right? That'd be another thing of canceling. And so either way, it's making 0, right? And so it's one of those two. So I'm going to multiply by the conjugate, 4 plus the square root of x. And I physically do not want to multiply in the denominator because that's going to muck up the fact that this is going to factor to be one of those two, and I can cancel it. I'm hoping that when I FOIL this out that I'm going to get that as well, and I do, don't I? Because when you FOIL, you don't have to worry about the outer and the inner when you multiply by the conjugate. So you get 16 minus x. So that's a beautiful thing. Here I'm going to go ahead and factor out an x, and I get 16 minus x. And so these I multiplied together, right? That's what gave me the 16 minus x. Here I factored this. I did the F word to it. And here is just what it is. And so these cancel out, leaving 1 in my numerator, and I've lost my limit. but I have room. I'll write it. So there's my limit. I haven't found my limit yet, but now I'm going to find my limit, because now that this is canceling out, it leaves 1 in my numerator. It leaves 16 out here, times 4 plus the square root of 16 when I plug in everywhere for x, 16. So this is 4 plus 4, which is 8, and 8 times 16, I think, is 128. I think I'll check it on my calculator, but I think that's it. And yeah, it is. So here is number 9 for the function whose graph is given, right? So it says the limit, it says if the limit does not exist, explain why. So as I'm going to -8, the limit doesn't exist, because if I look on the left, I'm getting -6, and if I look on the right, I'm getting -6. So this is -6, and it said I'm okay to just say that. And then f at -8, well, that's exactly at -8, and that's -3, right? So a limit says get on the left, get on the right. How close can you go? What is your output getting closer to? So at 6, well, at 6, I can see that as I go closer to 6 from a little bit smaller than, that I'm getting very close to 2. So I'm going to be saying my left limit, and you could use notation like this. The limit as x goes to 6 from the negative side of your function. I'm okay with you saying left limit or saying this notation, either one. Both are good. You're telling me this is 2, but that is not equal to the right limit, which is the limit as x goes to 6 from a little bit above, which is 5. And so this is why I'm saying this does not exist. And you don't have to, some people wrote a sentence, and that's wonderful. To me, this is the essence. Why doesn't it exist? Because the left limit doesn't equal the right limit. Now it says, what about from 6 from a little bit smaller than? Well, we found that right here, right? And so that work right here didn't say that I had to justify my answer, but there's my answer right there. And then here, -2, getting close to -2, and I see, oh, okay, it doesn't exist again, so I have to show some work here. So the left limit as x, so here I am writing a lot, that was approaching 3, whereas the right limit looks like it's going to positive infinity. They're not equal to one another, so this does not exist, right? And so that was the story on that one. And then long story short, last one for us to do, it's asking me about going to 3. And I can see that if you're, remember, a limit means check before, a little bit before 3 and a little bit after 3. So I can see that if I checked a little bit before 3, I would be using this function. And if I checked a little bit after 3, I would be using that function. And nobody told me to check exactly at 3, right? And so I need to show that the limit as x approaches 3 from a little bit smaller than, which the function that I would use, there's no reason for me to put g of x, the function that I would use if I'm a little bit smaller than is 2x. And this is a polynomial, so I could use substitution. This is 6. Versus, right, this was my left, and you need to look at your left and your right. And my right is the limit as x approaches 3 from a little bit bigger than, which is 2 minus x squared. So when I plug that in, that's 2 minus 3 squared, which is -7. These are not equal to one another. So that means that this limit does not exist. And so I definitely, all limits, you should justify your answer. And so I need to justify my answer on this. And so I need to look, because 4, right, going to 4, a little bit before 4 and a little bit after 4. So it might be like this one. So I need to show that the limit as x goes to 4 from a little bit smaller than, which is 2 minus x squared, is equal to, or is it not equal to? That'll help me make my decision. So I have to look at the left and the right. Left, right, right? That's a marching song. And so let's see here, x minus 18. So when we plug in here, we get 2 minus 4 squared, which is 2 minus 16, negative 14. And when we plug in here, we get 4 minus 18, which is negative 14. They are equal to one another. So that means that is the reason that we can say that the limit as x goes to 4 of g of x is negative 14. And so that's the story. Okay, bye.